Assalamu alaikum. I am your host Muhammad Shiraz. Once again, welcome to the program Computer Programming Concepts launched by Allama Iqbal Open University for the guidance of BS Computer Science students. This is our program number 11, and in this program we will study about loops. Dear students, in our earlier programs we discussed about two types of instructions: sequential statements and decision control statements. In sequential flow, we studied that the flow of control is such that the instructions are executed in the specified order. Then we studied about decision control statements, and in that topic we discussed that we may alter the sequence of execution of instructions by introducing decision control statements. In decision control statements, we studied that a statement or block of statements are executed on the basis of a specific condition. But in both those type of statements, the instructions are executed at most once. Today we are going to study how to execute a statement or block of statements many times. For this purpose we use loops. So let's start our today's discussion of loops. Today we will discuss what is loop, what are different types of loops, which includes for loop, while loop and do while loop. In today's program we will discuss about for loop. What is loop? A loop can be simply defined as a loop is a statement that repeats a block of statement again and again until a certain condition is satisfied. Normally, a statement of the program is executed only once in the specified sequence. Loop has the property of repeating a block of statements repeatedly many times. The body of loop may be composed of a single statement or more than one statement. A loop should repeat its body finite number of times. If a loop repeats infinitely, then it is called infinite loop. The following types of loops are used in language C: for loop, while loop and do while loop. For loop is used with for keyword is shown on the slide. For loop repeats a block of statement specified number of times. It is also called pre-tested loop. Why it is called pre-tested loop? It will be discussed later on. General syntax of for loop is as: the body of loop starts with for keyword followed by the declarator statement, which has three sections enclosed in parentheses. The first section is called loop counter initialization section. Then we put a semicolon to separate this section from the second one. Then there is a section for loop condition checking, and followed by a section where we can change the value of the loop counter either by incrementing or decrementing. Then the body of loop starts with opening braces and its body closes with closing braces. In between the opening and closing braces we may put many statements, and these statements are considered as the body of for loop. These statements will be repeated many times at the time of execution of the for loop. The for loop allows us to specify three things about a loop in a single line. This is a special property of the for loop. In the first section, we set a loop counter to an initial value. Then we test the value of the loop counter to determine whether its value has reached the number of repetitions or not. And we need to change the value of the loop counter either by increasing or decreasing or by any other manner so that the loop body is ultimately closed. Let's study an example of the for loop. In this example, we declare a variable I of integer data type, then followed by the declaration statement is for keyword. For is followed by parenthesis, and inside the parenthesis is the loop declarator statement. In the first section, we initialize loop counter to the initial value 0. Then we check a condition I less than equals to 5, and we change the value of the loop counter by incrementing. We change the value of the loop counter by using increment operator. Dear students, this program will be executed in such a manner so that first the loop variable is declared at line number 3, then at first instance loop counter is initialized to the value 0 for the first time. After the initialization, loop condition will be evaluated. This time the value of I is 0, so it is evaluated whether 0 is less than equals to 5. Yes, the condition is true for the first time, so control will move inside the loop body. Inside the loop body, there is a statement at line number 6, printf, that will display the current value of the loop counter. So here the message will be displayed, value of loop counter I is equals to %d, and then followed by comma and I. When this statement is executed, it will display a message is shown on the slide, value of loop counter I equals to 1. When the first cycle is completed, control will jump automatically to the increment statement. There the value of I will become 1, then the condition I less than 5 is the current value of I is 1 and 1 is less than 5. Again the condition is true, and thus control will move inside the body of the loop, and the statement at line number 6, value of loop counter I equals to 1 will be displayed. Then when control reaches the closing braces of the loop body, from there it will jump automatically to the increment statement. There the next value of I will become 2. After changing the value of I, the condition I less than equals to 5 will be evaluated. As the current value of I is 2 and 2 is less than 5, therefore control will move inside the loop body, and thus again the current value of I 2 will be displayed on the computer screen. When this cycle is completed, again control will jump to the increment operator, and there the current value of I will become 3. After changing the value of I, the condition I less than 5 will be evaluated. Again this condition is true, thus loop body will be executed, and the message value of loop counter I equals to 3 will be displayed. When this cycle is executed, then control will move towards the increment section, and the value of I will become 4. After changing the value of I, loop condition will be evaluated. I less than 5 is the current value of I is 4 and 4 is less than 5. Loop condition is true and thus control will move inside the body of the loop and the message value of loop counter I equals to 4 will be displayed. Then control will move towards the closing braces of loop. From there it will jump towards the increment section. There the value of I will become 5 and then the condition I less than 5 will be evaluated. At this instance the value of I is 5 and 5 is not less than 5, thus loop condition will turn out false and thus control will jump outside the loop body and the statements followed by the loop body will be executed. So dear students, you observe in this example that for the first instance the initialization section is executed and the loop condition is evaluated. Then loop body is executed, and when the first time the loop body is executed, control jumps toward the increment decrement section. There the value of the loop counter is changed. Then each time similarly when the loop body is executed, the value of the loop counter will be changed and then loop condition will be evaluated. If the condition turns out true, then body of the loop will be executed and then the value of loop counter will be changed. This process will continue until the loop condition turn out false. When loop condition turn out false, then control jumps to the statements followed by the loop body and thus loop cycle is terminated. Let's exercise this example on the computer. This is the example that we studied on the computer. We declare a variable I, then we initialize I to 0, we check the condition, and inside the body of loop there is a statement that displays the current value of the loop counter. Compile this program. Compilation report says there is no error. Okay, then execute the program. You see on the computer screen that the loop body is executed 6 times because in the loop condition we use I less than equals to 5. If we make it I less than 5, then it will give the same result as we studied earlier. Now the loop has been executed. The statement inside the loop body is executed 5 times and we are waiting to close this program. Let's study one other example. Dear students, you should remember that it is not necessary to change the value of the loop counter by incrementing its value. We may decrement the value of the loop counter as well. This is another example of the for loop. In this example, we declare a variable I. In this case, the body of loop is executed on the value of variable I. That's why we call I as loop counter. We initialize I to the initial value 5. For the first time, I will be initialized to 5 and then the condition 5 greater than 0 will be evaluated. This condition will turn out true. That's why control will move inside the body of loop and thus the current value of I will be displayed is 5. Then the value of I will be changed by decrementing. The new value of I will become 4. The loop condition will be evaluated. 4 is greater than equals to 0. Yes, the condition is true and thus the current value of I, that is 4, will be displayed on the computer screen. Again, the value of I will be decremented by 1 and the new value of I will become 3. 3 is greater than equals to 0. Yes, the condition is true and thus the new value of I will be displayed on the computer screen, that is 3. Again, the value of I will be decremented by 1 and the new value of I will become 2, and 2 is greater than equals to 0. Yes, the condition is true, and thus the current value of I will be displayed on the computer screen. Again, the value of I will be decremented by 1, and new value of I will become 1. The condition 1 is greater than equals to 0. Yes, the condition is true. Loop body will be executed, and the current value of I, that is 1, will be displayed on the computer screen. Then the value of I will be decremented by 1. New value of I will become 0. 0 is greater than equals to 0. Yes, the condition is true, and control will move inside the body of loop, and the current value of I, that is 0, will be displayed on the computer screen. After the execution of this cycle, the new value of I will become -1, and -1 greater than equals to 0. Condition will turn out false at this time, and thus loop execution will be terminated. Let's exercise this example on the computer screen. This is the same example. Let's see. When this program is executed, you see that we executed the loop by decrementing the value of I 6 times. Let's study another example of loop. By this example, we want to calculate the sum of all digits between 10 and 20. I just want to explain you people that it is not necessary to start a loop from the initial value 0 or 1. You can initialize loop counter to any value, and you can execute the loop up to any number of times. It is not necessary to execute the loop 5 times. In this example, we declare a variable I as a loop counter, and then we declare a variable sum, initialize it to the default value 0. Then we initialize loop counter to the initial value 10. I equals to 10 first time. Yes, the condition I less than equals to 20 is true. Control will move inside the body, and the current value of I will be added to the sum. Then loop body will be repeated by incrementing the value of I to the new value. New value of I will become 11. 11 is less than equals to 20. Yes, so 11 will be added to the current value of sum. Then loop body will be repeated by increasing the value of I to the new value 13. 13 is less than equals to 20. Yes, the condition is true, and thus 13 will be added to the current value of sum. This process will continue by increasing each time the value of I will be increased by 1, and then the condition will be evaluated. The process will continue until the value of I becomes greater than 20. When the value of I becomes 21, then the condition 21 less than equals to 20, this condition will turn out false, and thus loop body will not be repeated. Control will jump to the statement followed by the loop body, and thus the statement at line number 8 will be executed, and that statement will be display the final value of sum. Let's exercise this example on the computer screen. This is the same example. We declared a loop counter I and sum equals to 0. Then we executed the loop 10 times by starting from 10 and moving up to 20. Compile the program. Compilation report says there is no error. Execute the program, and it shows the sum is 165. This is the sum of digits between 10 and 20. Let's study another example of loop. This is another example of loop In this example, we want to display the list of even numbers and odd numbers between 10 and 20. You see that the body of loop may contain many statements, and in this specific example you should notice that the body of loop contains an entire decision control statement. So you should remember that the body of loop can contain any sort of statements inside it. All the statements inside the body of loop are repeated specified number of times. That is, the statements inside the body of loop are repeated until the loop condition turns out false. So in this example, we initialize I equals to 10, then the condition I less than equals to 20 will be evaluated, and for the first time the if condition 10 modulus 2 equals to 0, this condition will turn out true because 10 divided by 2 returns the remainder 0, and thus the message even number and then the value 10 will be displayed on the computer screen. Else block will not be executed as if block has been executed. Then loop body will be repeated, the value of I will be increased by 1, new value of the loop counter I will become 11, 11 is less than equals to 20, yes, condition is true. Then inside the body of loop, the statement at line number 6, if 11 modulus 2 equals to 0, this condition will turn out false, is 11 is not divisible by 2, thus the else block will be executed and the message odd number 11 will be displayed. This process will continue until the value of I becomes 21. At that instance, I less than equals to 20, this loop condition will turn out false, and thus control will move the statements followed by the loop body. Let's exercise this example on the computer. This is the same program. Compile this program. Compilation report says there is no error. Then execute it. You see even number 10, odd number 11, even number 12, odd number 13, even number 14. All the odd and even numbers between 10 and 20 are separated by this loop. Let's study one other example of the for loop. Dear students, I told you earlier that while using for loop, we initialize the loop counter, we check the loop condition, and we change the value of loop counter in the same line. But it is not always necessary. You may change this syntax as shown in this example. In this example, we declare loop counter I and initialize it at its declaration to the initial value 0. Then it is not necessary to initialize it over here. Just put a semicolon and keep the section preceded by semicolon over here is blank. Check the loop condition. I also do not use here the increment or decrement statement to change the value of the loop counter. I want to change the value of the loop counter inside the body of loop. That's why I put just a semicolon and I kept the section followed by semicolon as blanked. Here in this specific example, for loop is followed by a loop condition, and the initialization and the increment decrement statement are used outside this declaration statement. Then inside the body at line number 7, we are changing the value of loop counter by 1, increasing by 1. Here this program will be executed such that first time I equals to 0, I will be initialized to the initial value 0. Then the loop condition 0 is less than 5, this condition will be evaluated and this condition will turn out true. Thus printf value of loop counter 0 will be displayed on the computer screen. Then the value of I will become 1 as the current value of I is 0, 0 plus 1, 1, new value of I will become 1. When control reaches the closing braces of loop, From here control will jump to the increment decrement section, but there is nothing, therefore the loop condition will be evaluated as 1 is less than 5, thus control will move again inside the body of loop and the current value of I will be displayed, that is 1, and the value of I will be incremented by 1 again, new value of I will become 2. This process will continue until the value of I becomes 6. At that instance the loop condition I less than equals to 5, this condition will turn out false, and thus control will jump to the statements followed by the loop body. Let's exercise this example on the computer screen. This is the same example. We declared loop counter and initialize it to the initial value 0, then we kept the initialization section as blank and the increment decrement section as blank, and this is the body of loop. Compile this program. Though we have changed the default syntax of for loop, but this is a valid syntax, therefore compilation report says that there is no error. Execute the program and we are receiving the same result. Value of loop counter is 0, then 1, 2, 3, 4 and 5. When to use for loop? For loop is used in situations when the number of execution is known in advance. So dear students, in today's program we discussed about for loop and we exercise different examples of the for loop. You might have noticed one common point in all the examples, that in for loop we use all the statements of the for loop in a single line. We initialize loop counter to the initial value, we check the condition of loop and we change the value of the loop counter in the same line. This is a major distinguishing feature of the for loop from other types of loop. We will discuss about other types of loops in next program. Till then, Allah Hafiz.